Good afternoon, and thank you all for joining today's web event, Capturing New Jobs, Growth Opportunities from Direct Air Capture Scale-Up. I'm Sydney Bach, Associate Director for Technology Policy at the Bipartisan Policy Center. Today's event is co-hosted by the BPC and Carbon 180. As the US economy transitions toward mid-century decarbonization, direct air capture technology can play an essential role balancing emissions across sectors that are difficult to decarbonize. We're already seeing direct air capture projects under development in the United States, and with broader deployment, there is the potential for new jobs and other opportunities for growth in major markets like steel, cement, chemicals, natural gas, and electricity. Today's event will begin with a presentation of the Rhodium Group's latest report that quantifies the significant employment and market opportunities associated with the scale-up of direct air capture. Our presentation will be followed by a moderated discussion with key stakeholders, and we reserve time for audience Q&A. A quick housekeeping item, please use the Q&A feature in Zoom to send us your questions for our presenters and panelists. With that, I'd like to introduce John Larson, Rhodium Group's Director for U.S. Power and Energy Systems Research and lead author of their latest report, Capturing Jobs. Welcome, John. I'll turn it over to you.
Thanks, Sydney. Thanks to everybody for joining us today. Thank you to BPC and Carbon 180 for putting on this event. Really happy to be here and appreciate everybody's effort in making this happen. I'm John Larson. I direct U.S. energy research at the Rhodium Group. We're an independent research firm that does a lot of work on federal and state policy, as well as early stage technology and energy systems research, looking at a variety of different areas of climate change and clean energy. And today, as Sydney said, we're going to be talking about the employment opportunities associated with the scale-up of direct air capture technology. I am going to share my screen. And walk you through the latest work that we've done in this space. Before I dive in, I wanted to say a couple things. First of all, thank you to Whitney Herndon and Galen Hilbrand, the analytical team on this project with me. They did a lot of the heavy lifting and really appreciate all of that. We also did a lot of engagement with the labor community and other key players in a variety of industries, and we appreciate everybody's time and input during the process. And last but not least, I want to thank the Linden Trust for Conservation for supporting the work. So just very quickly to level set things here, let's talk about what the technology we're actually focusing on today. Direct air capture is a mechanical process that uses electricity and heat and engineering processes to take ambient air and capture carbon dioxide out of that air and produce a pure pressurized stream of carbon dioxide. That CO2 can then be used in utilization through food and beverage, a variety of different products and activities, or you can take that CO2 and put it deep underground in geologic formations. If you do this last step and put and store the CO2 underground, you can, so long as you're using clean energy to drive the machine, the direct air capture machine in the first place, you can have net removal of CO2 from the atmosphere. So effectively the opposite of emissions as we think of it today in the climate change context. This technology is not just an imaginary pipe dream. This is a real thing. As Sydney said, there's multiple projects in the pipeline here in the United States. There's multiple companies operating around the world with this technology. It works, it's ready to go. Rhodium put out a report last year that surveyed the state of play of the technology and found that this technology is essentially commercially available now and ready for scale up. what we also found last year when we looked at direct air capture is that we asked the question, okay, what's the US going to need with regard to direct air capture technology deployment by mid-century to get to a net zero emission reduction goal? And the answer is a lot. Even if the US does everything right on all fronts for deep decarbonization, does everything all the papers say you're supposed to do, you electrify as much as you can, you go big on energy efficiency, you decarbonize the electric power sector, use carbon capture and hydrogen to decarbonize industry, you improve the carbon sequestration in natural systems and forests and soils, you're still going to need something on the order of 600 to over 2 billion tons of direct air capture and storage capacity by 2050 to get the US to net zero. Now, why is that? It's because the US is a big emitter. There are a variety of sectors where it's just very expensive to cut those emissions, and direct air capture actually comes in as a cheaper option. And there's just a lot to do here. The low end of this range represents everything going great on all other decarbonization fronts. The upper bound is illustrates a world where we maybe don't electrify fast enough, or there's not enough energy efficiency, or not enough hydrogen scale up. And so direct air capture has to pick up the slack to get to a net zero outcome. And when we finished this report, one of the questions that came up in our heads was, well, that's a lot of construction, that's a lot of manufacturing. What are the employment opportunities that could be associated with scale up of this new technology? And given that it's new, the answers weren't out there yet. So we wanted to dive in deep and take a look at what direct air capture could mean for jobs in America. So just to show you what we're looking at in this analysis, we've kind of broken the job opportunities into 3 different buckets. There's construction and capital. This is the jobs associated with designing the plant, building the plant, and some of the key materials that go into the plant, like cement and steel. Then it takes energy, as I said, to run these direct air capture plants. So we look at the jobs upstream in electric power and potentially natural gas that could be used, that could be associated with direct air capture energy consumption. I should say that energy needs to be low or no emissions, so either renewables or nuclear or natural gas with carbon capture. And then lastly, on operations, the jobs associated with actually running and maintaining the plant, and the jobs associated upstream with producing the chemicals needed to capture the CO2 at the plant. So those are the categories we looked at. And then we were able to break things down. And I should say there's different technologies out there that direct air capture, that qualify as direct air capture. And the answer to some of this is all a little different depending on which technology you're looking at. We don't know which technology is going to lead in the end. Perhaps a thousand flowers will bloom. And so therefore we've kind of averaged things out across the state of the technology to make sure we're not overstating the outcome for any one type of operation. But with that, looking at a typical 1 million ton or megaton capture capacity direct air capture plant in America, we calculated that for every plant, you could see in the US up to 3,400 jobs. The vast majority of those jobs are associated with plant investment. In particular, the vast majority, almost half of total jobs, are associated with the equipment that goes into the direct air capture machine. So there's a variety of different specialized machines that you need to get CO2 out of the atmosphere and pressurize it and get it underground. And we quantified the jobs associated with the manufacturing to make that equipment, get it to the plant. In addition to that, these are very large facilities, roughly the same size as a moderately sized fossil fuel fired power plant, just to give you a sense of scale. That means construction and engineering jobs are substantial. Somewhere around 720 for construction and 650 for engineering for a typical direct air capture plant. And then the other inputs you need to make the plant work, such as cement for foundations and steel for structure and siding and all, and pipes and everything like that, is another substantial area where jobs can be created, specifically 139 jobs for steel and 10 for cement. And then looking forward, as you operate the plant, there's 278 jobs associated with operating and maintaining the plant that's on site. And then upstream, where energy and chemicals come from, you can see there's also additional ongoing jobs for energy, for the energy needed to run the plant, and for the chemicals. This gives you a kind of a good overview of kind of, if you were going to build one of these in a state, kind of what the employment opportunities would be. Obviously, with the precipitous decline in jobs in America in a very short time period here in the pandemic, this type of information is actually pretty interesting as far as giving, as far as new employment opportunities that could get people back to work. From here, I wanted to, so this is just the typical 1 megaton DAC plant. The next few slides, I wanted to put these jobs into context, going across some key sectors to show you not just how many jobs are created with any 1 megaton of direct air capture, but with the mid-century scale up of the technology that we identified, how many jobs we're talking about out into the future to 2050 on that are associated with this technology, and how that compares with the sectors today. So first of all, industrial equipment. Today, 2018, 140,000 jobs in America focused on industrial equipment manufacturing. We find that, you know, as you follow that same deployment scale-up pathway I showed you earlier for direct air capture, the number of jobs required or associated with building the equipment that goes into the direct air capture plant scales up substantially. And we actually see just equipment for direct air capture in 2050 could be greater than current US employment in industrial equipment today, somewhere in as high as 222,000 jobs in 2050 working on making machines that go into direct air capture plants. Further onto construction, construction is a huge industry. People work building all sorts of factories and buildings all over the country, but we still find that in 2050, just construction jobs needed to build direct air capture plants in 2050 could be as much as a third of current construction jobs today. Moving over to engineering, there are a lot of engineers in America. But even then, a meaningful, definitely six digit, almost 250,000 jobs, as much as that much for engineering jobs associated with building these plants. And then turning over to steel, there's roughly 27,000 jobs in the manufacturing of steel products in America. So that does not include jobs at blast furnaces, just like doing basic steel production. But just in this subsector, we see the total demand, the total employment opportunities for finished steel manufacturing can be as much as 20,000 to 50,000 jobs, which could be up to 50% greater than current jobs today. And the interesting thing about steel is there's actually more to the story here. We only looked at direct jobs associated with these plants, but there is obviously more jobs associated with the steel mills actually making the basic iron and steel production in the first place that then goes into these manufacturing processes. On top of that, there is going to be scale up of clean energy to power these plants. And turns out wind turbine, solar, nuclear are all steel intensive opportunities as well. And so there's actually probably even more job opportunities for the steel sector here beyond what we report, depending on how the rest of the equation shakes out over time. On cement, We find that up to about a third of current cement employment could materialize just to service the construction of direct air capture plants in 2050. And then finally, one last chart is looking at the jobs associated with actually running and maintaining these plants. We actually find that if you're up at the upper bound of our range, we could have a lot of people hired and employed working just to run these plants relative to total industrial repair and maintenance jobs today. And so, a lot needs to happen to see this through, but it's really interesting to see the opportunities here. So then just some closing thoughts before I turn it back to Sydney. The first thing to note here is none of what I just showed you is set in stone. Direct air capture is an early stage technology. It needs near-term deployment support to get multiple plants built, get steel in the ground, get the cost down, get experience with the technology, get commercial supply chains behind it so that it can scale up to where it needs to go at a reasonable and be a key component of America's decarbonization strategy out to mid-century. And so there needs to be more federal policy action to make that happen. And if you look back at our report from last year, we have a lot of great ideas on that front. You're also going to need some sort of long-term federal policy framework out to the mid-century to catalyze, to deal with climate change generally, but also to make give direct air capture the framework it needs to take off and play the role that we see it potentially playing by mid-century. You're going to need all of that to happen for these jobs to materialize. And there could be any number of components of a economic recovery package that could support the first steps down that road. When it does come to jobs associated with direct air capture, we see construction, engineering, and equipment manufacturing being some of the areas with the biggest upside with direct air capture scale up. I mentioned steel has a lot of opportunities, both in direct jobs, just with the plants themselves, but then way beyond that. And you're going to need a lot of people on site to run these plants. Maybe one more thing to think about is that for the variety of jobs we're talking about here, we're talking about high-wage jobs. We're talking about highly skilled construction, engineering, manufacturing jobs that are high quality and going to be really important to any kind of near-term recovery in America and to the future of this country in a deep decarbonized world. The last thing I'll say is the employment report is available on our website today at rhg.com. On top of that, we have a companion analysis looking at the business opportunities associated with direct air capture scale up. And so we found a lot of really interesting stories for companies that operate in some of these key sectors. And so I encourage you to take a look at that as well. And with that, I want to say thanks again to BPC and Carbon 180 for having us today. And I'll turn it back over to Sydney.
Thanks, John. So we do have a couple of questions that came in. So I think we'll take a few minutes before our panel to go through some of these questions. So John, I'm not sure if you're able to see them, but maybe I'll start off with the first one. Equipment manufacturing accounts for a majority of jobs. Currently, where's the equipment made? Will U.S. industry easily absorb these jobs, or will the equipment be made elsewhere?
So I think part of the answer to that is it depends on a lot of things, such as trade policy and any kind of U.S. Economic policy in response to the current pandemic and recession we're encountering right now. U.S. equipment manufacturing is, I showed you the U.S. jobs. There's, it's a global market. There are any number of component manufacturers here in the U.S. that could readily provide equipment to these machines, but there's also international competitors. So, I think we'll have to, I don't think it's safe to say that 100% of this is going to be American without some policy action, but there's I think the sector is diverse and capable, and we've got time for it to scale up to service that. And I know actually people on the panel are actually building these machines, so we can talk to them about it too.
Great, thank you. And we have one more question. Given the large amount of steel, concrete, et cetera, required to build DAC facilities, what are the life cycle analysis conclusions? For example, how long will it take running the plant to pay off the embedded CO2 invested in the plant?
Yeah, it's a great question. And, you know, at the moment, cement and steel are relatively energy and carbon intensive manufacturing processes compared to other materials. That is true. We're also talking about long-term scale up in the context of deep decarbonization of the U.S. energy system, of which, you know, you're going to need to see technology innovation and improvement in cement and steel and pretty much everywhere else to get to net zero. So we've not done a life cycle analysis around to answer the question specifically, but I guess the key point is that with direct air capture scale up, it's one more reason to think of holistically about decarbonization and making sure we have innovation and clean technology deployment across all sectors to make sure that we can actually do all of this in a reasonable way.
Great. Well, thank you so much. I know that there are a few more questions and we're going to reserve those for our panel discussion, but thank you, John. And now I'd like to introduce Ugbad Kosar, Senior Policy Advisor with Carbon 180, who will moderate today's panel discussion. Ugbad?
Thank you, Sydney. It's great to be here today. Before we begin, I want to just draw attention to the Q&A box again. Please feel free to throw in any questions you may have about the report or for our panelists. We're going to start with a moderated discussion and then move into open Q&A. So at that point, I'll be pulling up from the Q&A box. Without further ado, I'm really excited to introduce a fantastic set of panelists that have been kind enough to join us today. First, I'd like to welcome back John Larson from the Rhodium Group. Next, we have Lori Gaytray, the Vice President for Business Development at Carbon Engineering. Lori leads the development of DAC-based decarbonization solutions in the United States. Lori brings more than 28 years of experience in the engineering, business development, and financing of complex mission-critical systems. Next, we have Jason Walsh, the Executive Director of the Blue-Green Alliance. In this role, Jason provides overall leadership and management of the organization. Jason brings more than 20 years of experience at the state and federal levels in policy development and advocacy in a range of issue areas from climate, clean energy, and economic and workforce development. And last but certainly not least, we have Roxanne Brown, the International Vice President at Large for the United Steelworkers. For 20 years, she served USW members from the union's legislative office in DC, but most recently as legislative director. Roxanne oversees the union's public policy and legislative agenda, as well as its political work. She has extensive experience in defense procurement policy, environmental regulation, and energy policy. So welcome, everyone. It's an absolute pleasure to welcome you. We're just going to jump right into the first question. So the COVID-19 pandemic has had unprecedented impacts on the lives of Americans. Can you share how COVID has impacted energy sector workers, and for carbon engineering in particular, how has it impacted your path forward? So Lori, would you be able to kick us off here?
Sure. Thanks so much, Ugbad, and thanks so much to the audience for your interest in direct air capture, and to the BPC and C180 organizers of this event, and to the Rhodium Group for such great work analyzing all the economic and job opportunities that would be created by direct air capture. At Carbon Engineering, we're fortunate that even while following the safe protocols required up here in BC, we've been able to continue our pilot plant operations as well as work on our first plant in the Permian Basin in the US. So we've had to adjust like all of you, but we've had no delays imposed by COVID. Our hearts go out to those who are impacted, and we're inspired by how the world has come together to address the challenge. We're hopeful that this might be a model for how we're able to lean in together as we all work on net zero and onward to climate restoration. the Carbon Capture Coalition in the US actually has some great recommendations out to Congress on the 45Q tax credit, such as direct pay and an extension. We'd like to see that point source carbon capture and DAC become part of the recovery if that's possible.
Thank you. Jason, do you want to add anything to that?
Sure. Hi, everyone. Well, maybe I'll start by you mentioned energy sector workers. I mean, let's recognize that, particularly in the utility sector, we've got a lot of workers who are keeping our lights on, keeping our heat going, keeping our water flowing through this crisis. They've been working throughout. They've been very much at the front lines. We have one of the Blue Green Alliance's partners is the Utility Workers Union of America. They work in utilities across sectors. One of their leaders, and this kind of stuck in my head, has compared going into a customer's home to fix a utility problem in the era of COVID as walking through a minefield. And a lot of these workers have stepped on mines. Utility Workers Union is not a particularly big union. They have 50,000 members. They've lost 15 of their members over the last 3 months, very much on the front lines. So let's just recognize that and honor it and do whatever we can to keep workers safe, which we can talk a little bit more about on this webinar. But of course, this is also the economic disruptions of this pandemic have resulted in a whole lot of workers in the energy sector losing their jobs. So clean energy jobs, we've lost maybe 100,000 since March. That was the fastest growing part of the energy economy. That is unfortunately only the tip of the iceberg. Manufacturing sector has lost maybe 1 million. Many of those workers produce equipment and components for the energy economy. And of course, the biggest of big pictures is that 46 million Americans have filed for unemployment insurance over the last 13 weeks. So as we start a conversation about economic recovery, let's just make sure we also keep our eyes on just basic economic relief policies, like, for example, extending unemployment insurance, which expires at the end of July, that is keeping families afloat and households whole and putting food on the table.
Building on this COVID conversation, Jason, what do you think has gone well with the federal response to COVID, and what do you think still needs to be done for a full recovery?
I'm going to try to be diplomatic here in how I respond to that question. I think probably enough has been said about how deeply inadequate and irresponsible the Trump administration's response to this pandemic has been. I will flag the issue of worker health and safety, since I just referred a bunch of utility workers who've lost their lives. The Occupational Safety and Health Administration, which is supposed to be the agency protecting workers on the job, has done virtually nothing under this administration to carry out their mission. They have issued guidance on keeping workers safe during this period as they work in their workplaces, but guidance is non-enforceable by design. Employers don't have to pay attention to it. And so we are in this remarkable situation where being at work or going back to work is a life or death issue for a lot of workers in this country. We see it particularly vividly with meatpacking workers right now as the economy attempts to reopen more. That is extending to other workplaces without some kind of coherent federal policy around worker health and safety. That will just proliferate. And I think the piece we have to keep our eyes on is that keeping workers safe on the job is inseparable from actually full economic recovery. If people are getting sick while they're going to work, they are not going to continue working, right? And businesses will close down, and we will see even more human tragedy and economic ruin than we've seen so far. The additional piece we need is significant federal economic stimulus to actually begin creating the kind of demand that will help this country and its millions of workers climb out of the economic hole that they're in right now. House Democrats, I think, have taken significant steps toward doing that. The infrastructure legislation that will be on the House floor next week is a huge step in the right direction. I would say that we also need to see some significant investments in manufacturing as well. We've got an opportunity here to modernize and transform our manufacturing base and retool it for a low and zero carbon economy. We're falling behind the rest of the world with that respect, which we can talk more about. Economic stimulus legislation is a perfect way of paving the way for that kind of a transformation and financing first of a kind or early stage projects with new technology like DAC. We did some of that with the Recovery Act of 2009. We should be able to do that again. The long-term impacts of that are going to be significant from an emission reduction standpoint and from a job creation standpoint.
Thank you. Roxanne, can I invite you to add any additional thoughts?
Sure. I think I really appreciate Jason mentioning unemployment insurance and the fact that that will expire at the end of July. And, that is one thing that was done well. I'll say, like Jason, I hesitate to use words like well and good when it comes to the federal response. But the fact that UI was extended to workers that don't traditionally get UI during a time where economically so many workers were devastated and continue to be devastated in this country was key. Additionally, the additional $600 in unemployment insurance benefits that workers received were critical and remain critical. So I would just lift that up, that's something that was actually done well that needs to continue, because when that stops, so many workers will be even further devastated and families will be even further devastated. So that's a response that we appreciated. I echo everything Jason said on an economic stimulus. One of the things that's been particularly frustrating for us as an industrial union is, the effort to move something infrastructure related has taken too long in terms of this response to what's happened with COVID. We're happy that House Democrats, dropped their $1.5 trillion bill yesterday, and we're happy that it'll be on the House floor next week. But we also expect it will stop when it gets to the Senate, and there will be no action. And that million manufacturing workers who are laid off right now that Jason mentioned, about 100,000 of which are my members, don't have anything, to look to in terms of an economic recovery coming out of this COVID crisis. If we look across the steel industry, we have production that is down essentially at all of our steel worker represented facilities across this country. If you look at cement, same thing. We have production that is down across a lot of steel worker represented cement companies in this country. Our union in particular is very much tied to infrastructure. People don't often think of the steel workers when they think of infrastructure. They think of building trades unions, right? The people who build the stuff. Our members make the stuff that go into infrastructure projects. So a significant investment in infrastructure right now would just be so important to getting steelworkers, back to work, getting facilities that have been idled back online. I will say that the harsh reality of this crisis is so many of those steel facilities were teetering on the edge before COVID. And I think that's the piece of it that I want to make sure that I highlight for this conversation is, for us, a recovery is not going back to business as usual, because business as usual was very precarious for manufacturing workers. So looking forward, we need to make sure that whatever recovery comes on the other end for manufacturing workers is something that actually is viable and is able to bring some facilities back online, because the harsh reality is some that were teetering are just gone forever. So I would just echo Jason's call for stimulus. Our members are really looking forward to a big, significant infrastructure and stimulus package moving to Congress.
Roxanne, just to stay with you here, the Rhodium report states that certain sectors like steel and equipment manufacturing may see up to a doubling in job opportunities by 2050 with the scale up of direct air capture. How do you approach linking recovery today with investments to open this opportunity up for future generations of workers?
So one of the things that I really appreciated about the Rhodium report, and I always appreciate Rhodium because they do such great work, are the sectors they highlighted are so key to everything that we do here in this country in terms of making this country run. Steel, cement, equipment manufacturing, chemicals, and fuels. And as I worked through the list of each of the facilities that Rhodium highlighted, it was actually quite interesting to me that all of the cement companies highlighted in the report are steelworker represented companies. All but one of the steel companies highlighted in the report are steelworker represented companies. All of the chemical facilities are steelworker represented facilities. 3 of the fuel companies are steelworker represented companies. And we make a lot of manufacturing equipment across this country. So for us, that's great. And at a very basic level, we want to make sure that those companies actually thrive and survive as time goes on, right? We love the fact that John walked us through, the role that each of these facilities, each of these industries can play when it comes to DAC and the materials. But if these industries aren't there for the long term, then everything that John walked through in terms of the jobs potential for these sectors is moot. So for us, industrial policy is key. And that includes a whole bunch of stuff like investing in infrastructure, like we've talked about. It includes investments in RD&D. It includes incentivizing companies to actually house themselves in communities across this country that have been devastated by manufacturing job loss. It includes investments in workforce training. And, of course, it includes the right to organize. John talked about the 278 O&M jobs at DAC facilities. Those should be union jobs, right? So all of that is a part of an industrial policy that has been absent for so long in this country. And, I feel like we're parrots in the Steelworkers Union and other manufacturing unions who are constantly repeating the need for industrial policy in this country. Obviously, it includes strengthening our trade laws, but we're parrots in this regard, and nothing happens. We're calling for it and nothing happens. So at a very basic level, that's what we need. We need to have pragmatic, strong, strategic industrial policy in this country to ensure that all of the industries that have been highlighted in this report will be there in 2050 so that we can realize those jobs numbers that are highlighted, or else it's pointless.
Yeah, thank you, Roxanne. That was really insightful. Jason, is there anything else that you want to add to that point?
Amen.
Perfect. All right. Let's just shift gears a little bit from COVID right now. Looking back 10 to 15 years ago, Lori, what do you wish was done differently in renewable energy or electric vehicle policy that could have led to better labor market outcomes in those areas today? And what are some of the lessons learned that can be applied to direct air capture?
Great, thanks. So I guess we've seen lots of successes in wind and solar and electric vehicles. But it's important to know that it took a patchwork of policies over many, many years to get renewable power and electric vehicles to the point where they're competitive in big markets. So for us, like any other technology, what we need to incentivize large-scale direct air capture is durable, perpetual, market-based mechanisms like the California Low Carbon Fuel Standard that tell us where to invest from a technology standpoint and that allow investors and lenders to deploy the capital needed to build this critical infrastructure. Policies are the pacing items. So the faster we have additional broad, clear policies that reward negative emissions, the faster we'll be able to build DAC plants around the world. I also want to echo something that's in the Rhodium report and that Roxanne said, that if done right, building out a carbon removal sector can be a big boost for businesses, equipment, and material suppliers, and many of the labor sectors that are threatened in this current energy sector.
Thank you. Roxanne, is there anything from the steelworkers' perspective that you think could be lessons learned for direct air capture?
I think, again, something else that's frustrated us for a very long time is, this country is so amazing when it comes to innovation, right? We're brilliant. We're the United States. We've created all of these technologies like wind, solar, but we now fall way behind the rest of the world when it comes to these technologies because we have not done enough to support them here and support the expansion of them here in this country. So I would just say, to Lori, because the work that you're doing is so great and so tremendous, look at those sectors as an example of what happens when those technologies aren't developed in a way that ensures domestic production of those technologies and domestic innovation of those technologies, because the rest of the world is ready and willing to take to basically take the lead where we fall.
Can I add something, Gwen? I mean, one of the lessons certainly that I feel like we've learned from the last decade of rapid deployment of primarily renewables technologies is that job quality matters. Right? We have created a lot of jobs in these sectors. But the job quality has been mixed. And it's because we have used as our federal policy drivers, at least at the federal level, primarily federal tax credits, which do not have prevailing wage standards and domestic content standards typically attached to them. We're trying to change that, I should emphasize. And that's an active discussion right now with respect to the infrastructure bill that's being formulated as we speak. But I think it is a lesson that we need to learn as we think about the continuing and deployment of DAC. Let's pay just as much attention to the quality of jobs that are created and supported as we do to the development and deployment of the technology itself.
Thank you, Jason. Before we get into the last question, I just want to remind everyone that the Q&A box is available. So if you have any questions for the panelists or for John about the report, please feel free to use it, and we'll try to get to it after this last question. Staying on the topic of renewables, electricity generation from renewables surpassed coal for the first time in history this month. As we continue to transition to clean energy and clean infrastructure, how can coal and fossil jobs evolve into direct air capture jobs? Jason, do you want to kick us off on this one?
Yeah, I'd be happy to. I'll start by being a little contrarian. I mean, I think we probably need to acknowledge that coal jobs are not going to evolve into DAC jobs because there is such a temporal mismatch, right? The coal economy, job losses in the coal economy really started skyrocketing in about 2012 when natural gas prices hit rock bottom and have continued apace since then. Will probably continue apace through the remainder of this decade. Whereas the job creation that would come from DAC deployment, as the Rhodium report very usefully, I think, illustrates, most of that job creation, if we do everything right, is clustered more in the 2040 to 2050 timeframe, right? So that's what I mean by the mismatch there. With respect to coal economy workers, I think the best thing we can be doing is making sure that we are supporting those workers and doing our very best to ensure that they can get into high quality career track jobs that pay at something close to the level of the jobs that they have been losing. And we frankly have not done a particularly good job of that as a country to date. We also need to be investing in the economic diversification of the communities in which they live, which is connected intimately to the kinds of new jobs that they can access. With respect to fossil fuel jobs, though, more broadly in that evolution, I mean, I think what the report makes crystal clear is that smart investments in the deployment of DAC will allow manufacturing workers and construction workers and utility workers to keep the jobs they have. Right? That's the best kind of transition policy, is keep letting workers keep the jobs they have and grow those jobs. And that's going to take the words that Roxy said earlier, industrial policy, combined with coherent climate policy, and a recognition that in the manufacturing sector, just as an example, it is not an insubstantial thing to shift production lines, right, from building one kind of equipment or one component to another kind of equipment or component, right? That takes capital investment. These manufacturers are operating on really thin margins. There needs to be some substantial public investment to allow them to do that if we're going to see the kind of scale of deployment that is envisioned by this report. It's going to take smart policy and both public and private sector investment that are aligned and complementing each other.
Roxanne, I know Jason mentioned a few points that you brought up earlier. Is there anything else that you'd want to share on this question?
It just is a reflection of just how beautiful symbiotic our work is and our relationship is. Jason and I think everything that he just said, I give an amen to you too. I wouldn't add anything else. That was perfection.
John, it'd be nice to hear from you. Is there anything that you'd like to share on this topic in particular?
Yeah, I mean, first of all, thanks to everybody for a great panel and reflections here. I mean, on this question specifically, I think that longer term view that Jason took is key here. We're talking decades. We're talking a lot of changes, not just for fossil fuels, but for a lot of different ways we move around in this country and use energy. And we don't know how it's all going to shake out. You know, one thing I think is a key takeaway from our work is that we do think if you're shooting for net zero by mid-century, direct air capture is going to be playing a substantial role. One interesting thing to know about direct air capture is that as long as you have access to affordable low carbon energy and good geologic storage opportunities, and depending on the capture process, you know, reasonable water resources, you can put these plants pretty much anywhere. Anywhere where those three things are existing. Turns out the U.S. has a lot of all three of those in a lot of places. So where, you know, once we're at scale, not tomorrow, not probably in the next few years, but like down the road, you could envision if there were an industrial policy or some other incentive structure for direct air capture as part of a broader decarbonization response in the U.S., a pretty deliberate siting strategy to help disadvantaged communities with this technology being placed and providing the economic opportunities around them in a strategic way. That's going to take some leadership and ambition, you know, just like all the other things we've talked about here today. But that is one interesting thing about this particular technology that I think is another reason to give it a look.
Thank you, John. We're going to wrap up the moderated panel discussion and just switch over to the Q&A unless there's any other last remarks from anyone. Perfect. Okay, so we'll just switch over. The first question is for John. Dr. Jennifer Wilcox last week said when direct air capture is fully scaled, it could at most remove about 5% of projected CO2 emissions. How does that square with your work, which seems to imply direct air capture is the quote unquote silver bullet in terms of removing CO2? And if she is right, how does that impact your job numbers?
Yeah, there's a lot there. So first of all, Jen's a good friend and has been an important advisor to us on this issue since we got started down this road a few years back. First of all, I'm not quite sure what the time frame or the geographic scale of that 5% is, but that would matter a lot to how we'd cross-reference that with our findings. If it's global and mid-century, that's a very different story. A couple of things I'd say. One is, it's not a silver bullet. I'll just say that, this is not some magic machine that's going to make it so we don't have to do anything else to deal with climate change. We need to do everything and this. So that's really, really important here. And in fact, the more we do on everything else, the less we need of direct air capture. So this is a dynamic situation that's worth keeping in mind. The other thing to say is that if you do look at global direct air capture needs and carbon removal from direct air capture, the US actually plays a very, very important role because of the geologic storage resources available in this country. They are literally world-class. There's 2 trillion tons of storage underneath the lower 48. And which means that if you are talking about 5% of global CO2, a lot of that 5% is going to happen here in the United States, simply because of that's where we have the available resources to put the CO2. I'm happy to follow up offline with more on that, but that would be my take.
Perfect. We can put you in touch with the person that sent in the question afterwards to follow up. And with that, we are going to wrap up this panel discussion. Thank you all for joining us today. I think it was a really important one, and I hope that it's one we continue to have. Lori, Roxanne, Jason, it was an absolute pleasure. And lastly, and John, thank you for the Rhodium Group's work on this report. I'd like to invite our Executive Director at Carbon 180, Noah Deitch, to close us out today.
Thank you so much, Ubad. That was a great discussion. I enjoyed it a lot. And let me just say thanks to not just all the panelists, but also to John and team at Rhodium and BPC for putting this all together. We've been talking about direct air capture on Capitol Hill since 2015. And back then, to envision that you fast forward to 2020 and we'd have such a wonderful conversation with such detailed analysis about the potential for DAC, it didn't seem possible at the time, but it's really, really helpful. And I think, to me, I keep learning new things from conversations and analysis like what the Rhodium team has put together. And I always talk about direct air capture as a technology. But what I think John's team has shown is that it can actually be an industry. And that's a completely different framing, and one that's really exciting. And look, I recognize it's 2020. It's hard enough to plan for Thursday, let alone a few decades down the road. But it's essential right now. And what I heard over and over from this panel is that policy is the key to this. It's the key to whether we get that new industry or if this just remains a niche technology. And it becomes essential to how we do it. Are we talking about good jobs? How many jobs are we talking about? Are we talking about those jobs here in the US or elsewhere? So I think the opportunity is really in front of us, and figuring out how we put that all together today is key. And Roxanne, I don't know if you have a t-shirt that we can buy that says pragmatic, strong, strategic, industrial policy, because I think that's the key. That's it. We need to figure out how to do that today, because we know that we can't continue to have fossil fuel jobs for forever. And as we look at the skill sets that are required here and the opportunities to build actual tangible things, not just software and services, direct air capture is a huge opportunity. And so my key takeaway here is that it's really essential to lay this foundation, and for us, we the people, to figure out how to do this in the best possible way. So thanks to everyone again for this wonderful conversation, and look forward to continuing the conversation over the years to come. And we get closer and closer to actually building some of those things right behind Lori's screen that we see, so we can actually get some real pictures very soon. So thanks, everybody. This is a wonderful session, and Ubad, great job with the panel discussion.
Thanks, everyone.
Thanks, everyone.
Thanks, everybody.
Bye, everybody.